So in this video, we're going to look at the equation of a circle. We're going to look at finding the equation of a circle and also using the equation of a circle to pull out pieces of information. So first we're going to take a look at where this is in the log table. So if you look at page 19 under the circle here, here is the equation of a circle when given center HK and radius R. So let's write that down for ourselves. So it's clear from this that the two pieces of information that you need is the center, so your x coordinate standing for your h here, and your y coordinate, your k, and your radius. So the radius length is also needed whenever you're looking for the equation of a circle. Right, let's jump into some examples here and we can start to see how we can go about finding the equation of a circle when given these two pieces of information. Okay, so let's take the following example. So find the equations of the circles. So I have a few of them here. We're going to take this one first, whose center is 2, 3 and radius is 5. They're the two pieces of information. So we can sub straight into our equation of a circle. Okay, so remember that is going to be the h, and this, of course, the y coordinate is the k, and the radius, of course, is 5. So filling those pieces in, it's going to be x minus 2 all to be squared plus y minus 3 all to be squared is equal to 5 squared. And so we get x minus 2 squared all to be squared, y minus 3 all to be squared is equal to 25. And you can leave it like that in that form unless the question has specified for it to be multiplied out. You don't have to multiply out these double brackets, which is what they would be, of course. X minus 2 all to be squared would be x minus 2 by x minus 2. But no, we can leave it in that form if it's not specified. Now we will take a look later on at equations of circles where they have all been multiplied out, because when it's all multiplied out and in that form, there's another way we can look at pulling out pieces of information. But we'll leave it at this for the moment. And let's take a look at the second example. So pause the video here and see if you can write out the equation of the circle whose center is minus 1, 4 and radius is 4. Okay, so h this time is minus 1 and the y coordinate, of course, is the k, there's your center, and the radius, of course, is 4. So now let's fill it in. So it is going to be x minus, and of course it's a minus 1. X minus, and the h is a minus 1. So it's x minus minus 1, all to be squared, plus y minus 4, all to be squared, is equal to, and the radius, of course, is 4 as well, all to be squared. So we can do a little bit of simplifying here because x minus minus 1 is the same as x plus 1. And of course, y minus 4 all to be squared. We'll leave that. 4 squared then is 16. And we can leave the equation of the circle like this. Okay, try this one. Again, finding the equation of the circle whose center is 0, 3 and radius 2. Pause the video and see how you get on with this one. So our h, of course, is 0, our k is 3, and our radius is 2 this time. So let's sub it in. It's going to be x minus 0 is the h, all to be squared, and y minus k is 3, and all to be squared, and the radius, of course, is 2 squared. So x take away nothing, of course, is just x squared, and then y minus 3 all to be squared we're going to leave, and 2 squared, of course, is 4. So that is just x squared plus y minus 3 all to be squared is equal to 4. And that is the equation of that circle. So note, when you have the center whose x coordinate is 0, we end up with just an x squared in the equation of the circle. Okay, try this question. Again, we're finding the equation of the circle whose center is minus 2, minus 4, and radius is 6. Pause the video here and see how you get on. Okay, so again, we have our h is a minus 2 this time. Our k value is minus 4, and our radius is, of course, 6. So it's going to be x minus, and then we're subbing in our h, minus 2, all to be squared, plus y minus, and then you're subbing in your minus 4 for your k, all to be squared, is equal to, and 6 squared is what we have there. So x minus minus 2, remember we can simplify that up. Taking away a negative is the same as adding. So we have x plus 2 all to be squared, plus, again, y minus minus 4 is the same as y plus 4 all to be squared is equal to 36. And again, we can leave it in that form. And last example in this question, we want the equation of the circle whose centre is 0, 0 and radius is 3. So pause the video and see how you get on with this. So the h value is, of course, 0. The k value is, of course, 0 as well. And the radius is 3. So this is when we have the centre being the origin. 0, 0, of course, is in the middle of the axis and is what we call the origin. So again, filling in our values, it's going to be x minus 0 for the h, all to be squared, plus y minus, and we have 0 for the k, all to be squared, is equal to the radius is 3 squared. So we can tidy this up. So x take away nothing is, of course, just x, all to be squared. Y take away nothing is y squared, and 3 squared is 9. So that leaves you x squared plus y squared equals 9. Okay, so remember with the equation of a circle, the two things we need, of course, is the centre and the radius to fill in to get the equation of a circle. Well, that also means if you're given the equation of a circle, you can figure out the two pieces of information that were used in order to create it. So, find the centres and the radii of the following circles. Okay, so I have a few listed down here. Let's take this one first of all. Pause the video if you feel confident with this, or listen carefully as we explain through the first one at least. So, following on from what we have here, the x coordinate, of course, of the centre should be 4, and the y coordinate will be 2, because this is set up perfectly where you've got the minus, you see. So if it's x minus 4, the h is 4, and if it's y minus 2, the k is 2. So the y coordinate of the centre is 2. And the radius has been squared, remember. So r squared is equal to 9, okay, which means the radius on its own is going to be the square root of 9. And of course, the square root of 9 is 3. So the centre is 4, 2, and the radius is 3. Okay, so take a look at this question. So here, of course, we have x minus 3, so the h, or the x coordinate of the centre is 3. And here we have a plus 1. Now, technically it should be minus something. So if there is a plus, it means it must have been y subtract a negative. So this y coordinate of the centre must have been minus 1. So that y minus minus 1 gives you the y plus 1 here in the brackets. So the centre is 3 minus 1 in this case, and the radius is going to be again the square root of 16, which is 4. Let's take a look at this one, and again pause the video if you're confident. So here the centre is going to be so what have we got? We have a plus. So again, it's got to have been minus a value. So if we have a plus here, it must have been minus 5 in order to get plus 5. So the x coordinate of the centre is minus 5. Here, well, I have nothing here. I just have y squared, which implies that the k must be 0. Because y take away 0 will give you y squared on its own. So the y coordinate of the centre must be 0. And again, the radius is going to be the square root of 100, which is 10. Okay, so let's try this question again, pulling out the centre and the radius. Pause the video if you feel confident. So this time, well, we have, again, nothing being subtracted from the x. We just have x on its own, all to be squared, which implies the x coordinate of the centre is 0. Same here, we have just the y squared on its own, which implies that the y coordinate of the centre is also 0. And the radius, of course, is going to be the square root of 81. You're always going to square root this answer because it has always been squared in the equation. So square root 81, so the radius is 9. Okay, so try this question. Pause the video if you feel confident. This time, of course, we have a minus 2, which is exactly what we would normally have, yeah, minus value. The x-coordinate is going to be 2. The y-coordinate, well, we have a plus here, so it must have been y minus 3, so the y-coordinate must be minus 3. And the radius, of course, is square root of 8. And square root of 8 doesn't root quite nicely, but that might happen. If you do it on the calculator, it will simplify the surge to 2 root 2. But that's as far as we can go with it, so that's the answer. Okay, so second last question of this type, x squared plus y squared equals 20. So again, nothing has been subtracted from the x here, so the x coordinate of the centre is 0. Same here, again, nothing's been subtracted from the y, so the y coordinate of the centre is 0, and the radius is going to be the square root of 20. And again, the square root of 20 doesn't simplify to a nice whole number. We just get 2 root 5 on the calculator if you simplify that surd. And that is our radius. Okay, so let's take a look at this. So let's just do what we did before. I want to first of all get the equation of the circle whose centre is 3 minus 2 and radius is 2. Okay, so I've just written this out for myself to have it ready to go. Again, this is what we get from the log tables. So this time, of course, that's my h value, and of course that is my k value. And my radius, of course, is 2. So I will sub all these values in. So what I get is x minus 3 for the h, all to be squared, y minus, of course, minus 2 is subbed in for the k, all to be squared, and then, of course, 2 for the radius, all to be squared. Okay, so we end up with x minus 3 plus, and then y minus minus 2 is, of course, the same as y plus 2, all to be squared, is equal to 2 squared, which is 4. Now, let's say we did have to multiply out these brackets, these squares here, okay, which may be required in the question. It depends. Mostly they are, as I said, happy for you to leave it in this form. But I want to show you as well how you can get the equation of a circle given to you in a different way. So, squaring this, x minus 3 by x minus 3 is of course what x minus 3 all to be squared is. And then y plus 2 all to be squared is y plus 2 by y plus 2, and then of course equal to 4. So knowing from our multiplying out double brackets, we've got to take the first term and multiply it to everything in the second bracket, and then we've got to take our second term, remember, and multiply it to everything in the second bracket. So we have x by x is x squared, x by minus 3 is minus 3x, minus 3 times x is minus 3x, and minus 3 by minus 3 is plus 9. And then here, similar thing, first term by everything in the second bracket, and then the second term by everything in the second bracket. So we've y by y, which is y squared, y times 2, which is 2y, 2 times y, which is 2y, and then 2 times 2, which is 4. And then, of course, equal to 4. Okay, so now what we can do is a little bit of tidying up here. And by tidying up, of course, with algebra, it means you can add together the things that are the same. Now, the only things that I have the same here is I can do the x's with the x's, I can do the y's with the y's, and I can add the numbers with the numbers. The x squared and the y squared, well, there's no other x squareds in it, and there's no other y squareds in it, so they are going to stay the same. So x squared plus y squared. And now I'm just going to link up what's the same. So I can add the x terms together. So minus 3x becomes minus 6x. Plus 2y becomes plus 4y. And numbers we can add together, plus 9 plus 4, which of course is 13, and then of course equal to 4. And now what we can do to tidy up the numbers here, because we have numbers on both sides, is take away 4 from that side and take away 4 from that side, and that leaves me with x squared plus y squared minus 6x plus 4y, plus 9 is equal to 0. And that is another way that the equation of the circle can be given to you. So when the equation of the circle has been totally multiplied out, it can be in this form. And when it's in this form, we can still pull out the centre and the radius by using these, okay? So this is also in the log tables on page 19. If you look down here, when you're given the equation in the multiplied out form like this, then the centre will be minus g minus f, and the radius will be this calculation, the square root of g squared plus f squared minus c. So let's take a look at this, okay? Let's take a look at this example and we can work through exactly how to pull out this information. So here is our equation and it's all been multiplied out. And we want to find, of course, the centre and the radius. So since plus 2gx represents the x term, okay, this is what is going to help us figure out what the g is, okay? And of course, it's minus g that we need for the x coordinate of the centre. And then, of course, it is plus 2fy, which of course is the y term. This will of course help us figure out the f. And when we take minus the f, that will be the y coordinate then of the centre. So let's have a look at that. So 2gx in this case is equal to minus 8x. They are the x terms. And 2fy is equal to the y term at minus 4y. Okay, so solving these to find g, well, if 2gx is equal to minus 8x, take away the x's, and of course we have that 2g is equal to minus 8. The coefficients of the x, in other words, the numbers or letters before the x is what we want to equate. And therefore, if 2g is equal to minus 8, g is equal to minus 4, dividing both sides by 2. And if g is equal to minus 4, minus g is equal to 4, which is what, of course, I need. I need a minus g. So the x coordinate of the centre is 4. Okay, let's have a look at this one then. 2fy is equal to minus 4y. Take away the y's. 2f is therefore equal to minus 4. And then divide both sides by 2. F therefore is equal to minus 2. Therefore minus f, change the signs of both sides. Minus f is equal to 2. And it's the minus f that we need for the y coordinate of the centre. So the centre is 4, 2. And now, of course, we're going to have a look at the radius, okay? So the radius is equal to the square root of g squared plus f squared minus c. Now, minus c, the c value, of course, is the number on its own at the end, okay? Which in this case, of course, is 11. So let's plug our values in. G we now know is 4. So the radius is equal to the square root of g, of course, is minus 4, so minus 4 squared, plus f is minus 2, so minus 2 squared, and minus c, of course, is 11. And doing that then on the calculator, we have the square root of minus 4 all to be squared, plus minus 2 all to be squared, and then minus 11. And we are getting, 11. Make sure we have it all in correctly. 3. So the radius is 3. Okay, so take a look at this example. And again, here is the equation that we've been given and we want to pull out the centre and the radius. Okay, pause the video and see how you get on with this one. So remember, 2gx can be equated to the x term here. So minus 6x is the x term. And 2fy can be equated to the y term. So plus 2y is the y term here. So let's equate them. So 2gx is equal to minus 6x. That implies that 2g is minus 6. And if we divide both sides by 2, we get g is equal to minus 3. And then we have 2fy is equal to 2y. That implies that 2f is equal to 2. Divide both sides by 2, and of course we get f is equal to 1. So now we of course need minus g and minus f for the center. So change the signs and we get 3 and minus 1. So the center is of course 3 and minus 1. Now let's have a look at the radius. So for the radius, we need the square root of g squared plus f squared minus c. So c, remember, is the value on its own, which in this case is a minus 6. Okay, so let's fill this in. That is r equals the square root of g is minus 3, all to be squared. F is 1, all to be squared, minus, and c is of course minus 6. So keep it in brackets there. All right, and now we'll just work this out. Square root of minus 3 squared plus 1 squared, take away a minus 6. And we are getting 4. So the radius is 4. Okay, so our final example, we're going to pull out the center and the radius from this equation. So remember, our 2gx will be equated to our x terms, and our 2fy will be equated to our y terms. Now, we have a bit of an issue here in that we don't have any y terms in this equation. We've only got a y squared term, but that is not what we need to equate this to. So that means straight away that the 2fy is equal to 0y. There is no y terms, which means that the 2f is 0, and then of course divide both sides by 2. The f is therefore 0. And of course minus f, which is what you need for the y coordinate of the center, is still 0 because minus 0 is still of course 0. So straight away I know that the y coordinate of the center is 0. So now let's have a look at what I do have with the x terms. So 2gx is equal to 10x, which implies that 2g is equal to 10. Divide both sides by 2. G, of course, is equal to 5, which means that minus g is equal to minus 5. And the radius, let's work this out, is g squared plus f squared minus c. C, of course, is the number on its own at the end, and we have a minus 75 for c here. Let's sub in all our values. G, of course, is 5, so 5 squared. F is 0, so 0 squared, minus, and of course, minus 75. Let's put that in on the calculator. So we have 5 squared plus 0 squared minus a negative 75. And the answer is 10. So the radius is 10.